So we continue further on vector spaces, which is an actually abstract concept. Abstract in the sense what? I think the Strang book also, PDF is also available on web. I will put that, but any book will do. It is a very common theme. So vector space. Vector space, I would like to try my level best to conceptualize the abstract concept within you. So this is somewhere a real number space. By a real number space, what we get, it tells us that it's a single real number which can be, again, to get a theme of real number space is not so easy, which can be infinitesimal to infinite, which can be infinitesimally small to infinitely large. The concept of zero on real number space is not so easy to visualize. Means if I have something, real number space, listen very carefully. If I have this much length, if it goes on doubling, its length will tend to infinity. And if each time it becomes half, next time half, next time half, next time half, it will be contracting to infinitesimal or zero. This is a real number space. So at least everybody of us is aware of a real space. Like that, a vector space is something, again, means Euclidean space and vector space, the idea should be very much clear. That, so a very typical way means we define vector space by using I, J, K or Ax, Ay, Az, but that I will again try. I think you must have watched Strang lectures. If you have watched, I don't know to what extent you understood. I will try my level best to make it simplified. Or if you have gone through, thought something, can you tell me whether the unit vectors I, J, K or x cap, y cap, z cap or ax, ay, az, by all three means we can specify it, are they necessary to define a vector space? And if they are necessary, what would you like to say? Can we define a vector space using Ax, Ay, Az? Now, if we say the answer yes, that they are required, then that limits the vector space to a 3D space. Three-dimensional is not a maximum dimension of vector space. So listen very carefully. Euclidean space is three-dimensional. Vector space can be much more than that. Much more than that. Listen now. I am trying my level best. If we start with 2D, then when we start with 2D, we can start with 1D also, but that is not a proper way. We start with 2D and we define that Ax. What is Ax? Ax is a unit vector in the direction of x-axis. Ax is unit vector in the direction of x-axis. Then we define another unit vector when we define, try to understand, when we define another unit vector, why do we define that as ay? Means this is unit vector ax. Then can I have this as another unit vector, say ak? Can I have this as another unit vector ak? And why that is not used?
Take some other decay, then it is associated with some other rates. So it is not totally independent.
But will it work? So you keep this on the back, on your background plane of thinking. So we say ax and ay. Now we say that what is vector in this 2D space? Listen very carefully now. A vector in this 2D space is any line joining origin to a point in the plane. A line joining origin to any point in this xy plane is a vector, and that belongs to vector space. Any vector or any line joining the origin and any point in the plane is defined as a vector. And also a vector space is a hypothetical entity. It is set of all such vectors. Means it is very important that if one vector, say u in the printed book bold, and in our convention bar, if u bar is a vector and v bar is another vector, both belong to a vector space. Vector space is a set of vectors. Set of all such vector means how the set is? It is a very interesting set. If u and v are two vectors in the set, then any linear combination of these two vectors, also belongs to the vector space V. Vector space capital V. Vector space capital V is not a vector. Vector space capital V is not a vector. Simple example. In the benches are there in the classroom. Classroom is not the bench. So vector space is a set of all vectors. And kutle vector, if u is one vector, v is another vector, then any linear combination a u or pu plus qv is also part of the member of the set. लक्षात लगा, वेक्टर स्पेस हा अशा वेक्टर्सचा संच आहे की त्याच्यामधले दोन वेक्टर, एक u असेल आणि एक v असेल, u जर त्या v चा पार्ट असेल, v जर का त्या कॅपिटल v चा पार्ट असेल, तर u आणि v चं कुठलंही लिनियर कॉम्बिनेशन त्याचा पार्ट असतं. राईट? सो as long as you are in this 2D, so all the vectors which join origin and a point in xy plane are part member of the vector space V. Now, suppose if I say that there is another point which is 0, 0, 2, another point which is 0, 0, 2 and the point is here, then the line joining origin and this point, the line joining origin and this point is now, can you construct a vector which joins origin and 0, 0, 2 by linear combination of ax and ay? Right? So ax and ay, any kind of linear combination, any kind of linear combination cannot be used to specify the given vector. Therefore, the vector joining origin and the point 0, 0, 2 is not member of this 2D vector space V. कळलं का? Line joining origin and any point residing in xy plane is a vector from to, म्हणजे रे आहे लाईन ने, from origin to that point, from origin to that point. So that line is a vector, is an arrow. So line joining origin and any point in the plane is belonging to vector space V. But the line joining origin and 0, 0, 2 does not belong to this vector space. Then there is a concept of, it is जर एखादं असं तर मी सगळं पाठच करीन तर देर इज डिफरंट टेक्निक, अतिशय सोपं आहे, तसं कितीही काय फार अवघड नाही. पण कॉमन सेन्स आहे, पाठ करणं काय आवश्यक नाही. यू आर इन थर्ड ऑफ इंजिनिअरिंग नाव. नाउ देर इज अ कॉन्सेप्ट ऑफ बेसिस ऑफ ए वेक्टर स्पेस. तर आता काय करायचं? ax, ay. Now if you want that all those vectors which are connections between origin and any point in this room, any point in this 3D space should be the member of the set. म्हणजे आपल्याला ओरिजिन आणि 3D मध्ये असलेल्या कुठल्याही पॉइंटला जोडणारी लाईन सुद्धा कव्हर करायची असेल, सो व्हॉट यू नीड टू ॲड वन मोर युनिट वेक्टर az. You need to add one more unit vector az. So when you add az, then ax, ay and az, ax, ay and az can be used to construct any vector from origin to given point. Now listen very carefully. I want, whether if you have watched triangle lectures and still unable to understand, then we have got some meaning for the discussion. If you have not watched triangle lectures, then still you should be able to understand if you still focus on the contents. So let us take a 3D space. Let us take a 3D space. How you define the vector? Something x plus something y plus something az. So, or in general, in a 3D space, in a 3D space, an ordered triplet. An ordered triplet is a vector. Listen very carefully. In 3D space, an ordered triplet of real numbers, which are the coefficients corresponding to unit vectors ax, ay, az, is a vector. Is it clear? What is a vector in 3D space? A vector in 3D space is an ordered triplet of real numbers x, y and z. X, y and z, and xax plus yay plus zaz. So in general, an ordered triplet, you can say, if I have got say P, so you can use P1 or Px, Pxax. To show its vector, you deliberately write like this, plus Py-Ay plus, so an ordered triplet Px, Py, Pz is a vector. So in a 3D space, an ordered triplet is a vector. What you are doing? You are checking the basis. Now, so now there is a definition of basis. What is basis? आता बेसिसला तुम्ही समजा मराठीमध्ये ट्राय आफ्टर लेक्चर एंड्स. बेसिसला मराठीत काय म्हणतात आणि वेक्टर स्पेस अटेंडन्स वेक्टर स्पेसची बेसिस म्हणजे काय? व्हॉट इज बेसिस ऑफ ए वेक्टर स्पेस? व्हॉट इज वेक्टर in a 3D vector space? An ordered triplet. So I have got a vector u. I can say vector u. While writing, you should write bar, u bar, and when unit vector you should use cap. So what is vector u? Vector u, you can say ux, uy, uz. Vector u is an ordered triplet, vector u. Then you may have vector v, vx, vy, vz. Now listen carefully. बेसिस आता बऱ्याचदा हे नेमकं सांगता येत नाही डेफिनेशन, परंतु ते कशी ऑपरेट होते हे सांगितलं तर डेफिनेशन आपोआप कळते. सो व्हॉट इज ए वेक्टर, व्हॉट इज बेसिस ऑफ वेक्टर स्पेस? लिसन व्हेरी केअरफुली. बेसिस ऑफ ए वेक्टर स्पेस is set of such vectors. Basis of a vector set is set of such vectors that using linear combination of them you should be able to specify all the vectors in the vector space. दिलेल्या वेक्टर स्पेसची बेसिस म्हणजे अशा वेक्टर्सचा एक संच की ज्याचं लिनियर कॉम्बिनेशन वापरून तुम्ही कुठलाही वेक्टर त्या वेक्टर स्पेस मध्ये कुठलाही वेक्टर स्पेसिफाय करू शकाल. पण त्यात अजून एक कॅच आहे. इट इज द सेट ऑफ सच वेक्टर्स using linear combination of which you can specify any vector in the given vector space, provided that it is with minimum length. म्हणजे बेसिस म्हणजे काय? बेसिस म्हणजे अशा कमीत कमी वेक्टर्सचा सेट using which you should be able to specify any vector in the given vector space. दिलेल्या वेक्टर स्पेस मधला कुठलाही वेक्टर स्पेसिफाय करता येईल, म्हणजे ज्या वेक्टरचं लिनियर कॉम्बिनेशन वापरून दिलेल्या वेक्टर स्पेस मधला कुठलाही वेक्टर्स दिलेल्या वेक्टरचं लिनियर कॉम्बिनेशन वापरून वेक्टर स्पेस मधला कुठलाही वेक्टर स्पेसिफाय करता येईल असं शक्य जिथं होईल तो म्हणजे बेसिस. पण किती पण नाही, मिनिमम. म्हणजे आता तुम्हाला सगळं सांगतो की तुम्ही टिप्स काढता, एक एक्झाम्पल आहे, एक शॉर्ट नोट्स काढता तुम्ही परीक्षे दृष्टीने. एक आता काय पेंडेमिक आणि एकंदरीत सगळं सोपं असल्यामुळे ते काय त्याचे व्हेरी इम्पॉर्टंट IMP असे पूर्वी शाळेत वगैरे असं असेल, IMP म्हणून तुम्ही ते करता. तर आता ते कम्प्लीट कधी म्हणता येईल की जे केल्यानंतर परीक्षेतला कुठलाही प्रश्न सोडवता येईल ते. पण मग आता एखादा काय म्हणेल, मग आता मी काय करीन, IMP म्हटल्यानंतर सगळंच लिहून काढायचं, मग इट हॅज गॉट नो मिनिंग. बरोबर आहे? म्हणजे काय, असं कमीत कमी लाईन्स मध्ये इज इट क्लिअर व्हॉट इज बेसिस. म्हणजे IMP म्हणजे काय, कसं IMP, आयडियल IMP कसं की जे वापरून कुठलाही प्रश्न सोडवता आला पाहिजे. बरोबर आहे? कुठलाही प्रश्न सोडवता आला पाहिजे आणि ते कमीत कमी असलं पाहिजे. IMP कागदावर तुम्ही लिहिणार ते कमीत कमी असलं पाहिजे, पण असं पाहिजे की काही सुद्धा चुकता कामा नये. लक्षात आलं का? So what is basis? Basis is set of all such vectors such that any vector in the given space should be described by linear combination of members of the basis. The vector space is a set of infinite vectors. Everything is there in the vector space. Basis is the set of minimum number of finite vectors such that means basis is again a set of vectors, is a finite set of vectors such that using linear combination of members of the basis you should be able to describe any vector in the given space. आता मी तुम्हाला हे करतो, एक एक्झाम्पल देतो. So if U is 302, V is 507 and W is 101 is a set. These are the three vectors, right? लक्षात आलं? In a 3D Euclidean space, U, V and W are three vectors. Now you answer whether U, V and W form the basis of 3D Euclidean space or not. No, why?
Why is 0?
Because if any vector which is having y component cannot be represented using. Okay. Now I will give another example. U is 1 1 1. Will this form the basis? Will this form the basis of 3D vector space? Why? Means you answered not by appendix. You must find some kind of your profession which is part of a, say, number series or some time series like that. First you try to guess it. First I said that it will not form. Therefore next would be form, and again what lacuna was pointed out is not there. Will this be a basis? The basis definition a basis of vector space is set of vectors that are linearly independent and span the vector space. काहीच कळत नाही. सोडलं आपण. So the vector space and its basis. So the basis should contain such, and this automatically reduces to number 3. So a set of vectors which are linearly independent and using them you can represent the entire vector space is basis. So when we start then can 0 0 0 be, can 0 0 0 be a member of the basis? 0 vector cannot be a member of the basis. You will come to know that. So we start with anything else. So let us say U as 1 0 0. U as 1 0 0. Then let us say that it is, we are in 3D space, so it is the first vector which we claim to be in the basis. We claim that, and at the beginning there is no problem in claiming U100, right? Then we search for another vector V. So what should be there? V should be other than A00, because if it is 200, what will happen? If I say V as 200, V can't remain the basis because V is 2 times U. So it must be other than A00. So is it okay? 1 1 0. no problem. It can be a basis. 1, 1, 0 can be a basis because 1, 1, 0 is not a linear combination of 1, 0, 0. And then W. Then what W can be? W can be this should be non-zero. This should be non-zero and anything else is permitted. It can be 0, 1, 1 or 1, 0, 1 or 1, 1, 1 or 0, 0. Then when U, V and W are the vectors, then we can say that these form a basis. We claim that these form a basis. Now, when I say that the basis is now complete, I should be able to prove that no other member than this can be in the basis. 1, 0, 0, 1, 1, 0 and 0, 1, 1 is the basis of the vector. It means now that any other vector S, so U, V, W, so is the basis. Now when should I say that it's a basis? Let there be some S. And I say hypothesis that S is also the member of the basis. Vector S is also member of the basis. Let this vector S be equal to Sx or S1, S2, S3. Let S be S1, S2, S3. Then how will you prove that S cannot be the basis, member of the basis? Show that there exists something into U plus something into V plus something into W as S. And can you show that? Can you show that? Let AU plus BV plus CW be equal to S. Right? What is S? S1 comma S2 comma S3, or you can say S1. You can use IJK, I think is important because cap, right? What you can follow whatever you like. I or A, whatever AX cap plus S2 AY cap plus S3 AZ cap is now A we don't use A because we are using AX, so we use B, C and D, right? There is no harm, but just we should take care. So BAX, BU means BAX plus CV means C AX plus CAY plus DW means DAY plus DAZ is equal to S1 AX plus S2 AY plus S3 AZ. And you simply find, if you collect, that B plus C AX plus C plus D AY plus D AZ is equal to this. So B plus C is S1, C plus D is S2, and D is this, right? So any fourth in a 3D space, so what is the dimension of vector space? Number of vectors in its basis is the dimension of vector space. Number of vectors in the basis is dimension of vector space, right? And what is the identity basis? 1 0 0 0 1 0 0 0 1 is the identity basis. 1 0 0 0 1 0 0 0 1 is the identity basis. And now remember that what is the property of unit vectors? Each unit vector is orthogonal to remaining one. AX, AY, AZ are the unit vectors. Using AX you can't construct AY. Using AX and AY you can't construct AZ. Like that, the number of unit vectors need not be restricted to 3. 3D is Euclidean space, and we can go beyond Euclidean space. We can go beyond Euclidean space, wherein AX, AY, AZ, AW, and we can go back, AV and so on. There can be as many number of what we can say unit vectors as the dimension of the vector space. So 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1 are the basis of a 4-dimensional vector space. Is it clear? So it is just that you should be able to define the orthogonal vector. म्हणजे काय, एक नवीन ऍड करायचा की जो म्हणजे, and again it's a brand new entity which cannot be prepared using others. So AX, AY, AZ, AW, and that can be go endless. So there can be 10-dimensional vector space, 20-dimensional vector space. Everywhere there would be identity basis, 1 and all zeros, then 0 1 and all zeros, 0 0 1 and all zeros. So this would be the basis. So vector space is again an abstract concept which is not so impossible to be understood. Only thing is that it is somewhat tedious, that the terminology and all those things is somewhat tedious, which if either you can memorize or you can recollect it with appropriate logic. I think it's enough for today.